Hello everyone, welcome back to another video. So today I'm going to talk about K-means clustering, another machine learning model. So in the last video, I have discussed about KNN, which is K nearest neighbors. So that can classify the new data point based on the nearest points. So as per the requirement, if I give K is equal to requirement number 345 something like that, and it will check the nearest points with that specific number, then it will classify the new data point as per the nearest points. So that is about a KNN, K nearest neighbors algorithm. So whereas this is a different algorithm, and this is a unsupervised machine learning algorithm. KNN is a supervised machine learning algorithm, and this is a unsupervised machine learning algorithm. Means we need to work on a unlabeled data. So k-means clustering is a unsupervised machine learning algorithm used for partitioning a data set into a set of k distinct or non-overlapping clusters. So if I have a data set without any labels, so the my model has to segregate the data into different categories as per the behavior or as per the characteristics of each data point. So similar data points will be segregated or partitioned into a set of k distinct or non-overlapping clusters. The goal is to group data points into clusters such that points in the same clusters are more similar to each other than to points in other clusters. So here is a detailed overview. So in the below image, you can see, so this is my original unlabeled data. So if I feed my this unlabeled data to my trained model, so if I'm using k-means clustering, so the my model has to read all the data points and group all the similar data points together. For example, after applying the k-means clustering for this unlabeled data, so this will become a labeled clusters. Machine will name like these category of clusters with some name. These because these are all similar characteristics. These are all the similar data points, and these are all the similar data points are clustered or grouped together, and these are all another set of data points with a similar characteristics or similar behavior. So that is what the claim in k means clustering algorithm, the segregate the data into different clusters based on the behavior of the data points. The similar points are grouped together. So this image says that if I have any unlabeled data after applying the k-means clustering, the unlabeled data has been transferred into labeled clusters. So here you can see, and as I said in the last video, we spoke about k nearest neighbors. So that is a supervised machine learning algorithm, and this is for unsupervised machine learning algorithm. So main difference is like, so in a supervised machine learning algorithm, so we know the data points, like for example, here you can see in the image, so we have different data points with a different shape, star and a plus sign and also a dot, something like that, and we are just intimating the machine to segregate as per the characteristics or as per the shape. So those are labeled. These are labeled with a circle name, these are labeled with a plus sign, these are labeled with a star sign, something like that. So data is labeled, and we are just intimating the machine to segregate as per the label or as per the characteristics of the data point. So here we have the labels, and we are requesting the machine to group the data points together with their uh, label. So whereas when we have an unlabeled data set where we do not have any labels and we don't know what kind of data points these are, so in when we are working on k means clustering, so machine has to cluster the similar behavior points together and the grouped points in a different clusters. So that is difference between supervised and unsupervised, or like labeled and unlabeled data sets. So here we have another example of how this k-means cluster algorithm works. So here you can see my sample data set. So this is before applying k-means clustering. So I have random data points with a different characteristics or different behaviors. So if I feed this data to my model, so machine has to categorize similar points together, like uh, this green color data points to be grouped in a green cluster. If I wanted to group this data as per the color, so one cluster has been grouped into the, I mean, all the blue color data points has been clustered or grouped together. So we named this as cluster 2, and red data points are grouped together in cluster 1, something like that. So this is how the model will, will once we are applying the k-means, the unlabeled data will become labeled clusters based on the similarities between the points. So this is before applying the k-means clustering, and this is after applying the k-means clustering. So that is about how k-means clustering algorithm will work. So let's jump into a practical data set. How can we apply this in theoretical uh, descriptions into a practical note. So so similarly, we need to import all the necessary libraries like pandas, numpy, seaborn, matplotlib, and I'm using this mall customers data set, so that I'm requesting machine to segregate the clusters. So here my data set has the customer ID and the gender of the customer and age, annual income, and spending score. So this is my basic data set. I'm gonna work on this mall customers data set. So this is how the data set look likes. This is annual income in 15K. So for example, if I take the first customer with the customer ID 1, who is a male, age of 19 years old, who has 15K, $15,000 annual income, is spending $39. So the category is 1 to 100, and he is spending $39 spending score. And if I look at the third customer with the customer ID 3, female customer with the age of 20 years, and the annual income is $16,000 annual income, and she's spending $6. She has a spending score of 6. So this is about a description about the my data set. So now I need to pre-process the data. If I wanted to look at the any null values present in the data set, so that df dot is null dot sum will give me any null values in the data set. So as we can see, we do not have any null values. Customer ID is filled with all the entries, gender, age, annual income, spending score, everything is, and everything has some values. None of the row or none of the element has a null value. So that is how we can pre-process the data. And if I have any null values, I need to drop those without impacting the distribution of the data. So now I need to select the relevant features for the clustering. I wanted to select this annual income and spending score. So this is my X. So I'm just selecting the relevant features: annual income in K dollars, $1,000, and spending score 1 to 100. So I'm taking these two features as my clusters, and I need to scale the data, because see here you can see here the income is in dollars, like it is 15 nothing but $15,000, and here the score is represented out of 1 to 100, it is 39. This first customer score is 39, and here second customer annual income is $15,000, whereas the score is 81. So I need to scale the data, because this has its own value and this has its own value. This is represented score of 1 to 100, and this is 15 nothing but $15,000. So with this original data, we cannot able to build the model. So I need to scale this data. So that is why I'm using this pre-processing standard scalar, and so my imported standard scalar, and I'm just importing this X. These two features I wanted to scale it. So so let me have a look at the data. So now I need to determine the optimal number of clusters. So I'm importing sklearn.cluster import k-means. This is how you can import k-means clusters algorithm from sklearn cluster. And so I'm just giving WCSS first. In the first instance, it's empty bracket for I in range 1 to 11. K means is equal to k means the algorithm which we imported. Number of clusters I'm giving I, because it will starts from 1 to 11, and random state I'm giving 42. And here my model has been trained, and I'm just using this append method. So if I wanted to plot this entire the to determine the optimal number of clusters by using the elbow method. So this is how you can see. And if I mean here I'm just training my model, and this is how the model is once we I mean model has been trained. And here in the graphical representation, so WCSS, if I have, and if I wanted to have one clusters, it has 400 points. And if I have two clusters, it is around 300. And if I have three clusters, number of clusters three, it is equal to around 180 or 150. And four clusters is around 100. And five clusters is around 75. Six clusters is around 50. And if I take 10 clusters, it is around 40 or 30, something like that. So this is how we can determine optimum number of clusters. So we do have different methods. Here I'm using elbow method to determine the optimal number of clusters. So now I need to train the k-means model. So my model, and I'm giving five clusters. I'm random state. I'm giving 42. Now I'm using this X scaled. This is my this is how I'm training the model with this X scaled data. With this X scaled data, because X has my two features, annual income and spending score. Based on these input features, I am just instructing machine to cluster it. And how many clusters I'm giving clusters as five clusters. So I want five clusters of these two features, input features, annual income and spending score. This has to be segregated into five different groups with the similar characteristics. With annual income, for example, if I have 1 to 10k in a one cluster, 10 to 20k in one cluster, 20 to 50k in one cluster, something like that, I'm just indicating the machine to segregate my input features into some readable clusters. So this is how I trained the model. And if I wanted to visualize the clusters, so plt.fig, I'm giving 10 and 10 versus 6, and my scatter plot X scaled here. K means, so this is how I'm giving the cluster one with a red color, cluster two with a blue color with these axes, and cluster three with a green color, cluster four with this color. So that is how I defined my graph. So to represent the visualize clusters. So this is how this is how the clusters are after training the model. So my input features are randomly feeded. Then after importing or after importing the data to the k-means clusters model, the data has been segregated into six clusters, 1, 2, 3, 4, 5. So six, this is the centroid. Sorry, I defined five clusters only. So five clusters, 1, 2, 3, 4, 5. And this is the centroids, and the data point red is for cluster one. So all the similar data points are grouped together in the data points with the similarities. And this is my second cluster, third cluster, and this is my fourth cluster, and this is my fifth cluster. For each and every cluster, we have a centroid, center point. So centroid for this first cluster, the centroid point is middle, and this is the centroid for this cluster blue. So this is how the data has been clustered together. So if I wanted to look at the original data, how my original data is before scaling. So this is my original data points. These are all not clustered. So here you can see unlabeled data points. Here we do not know, by looking at this point, we don't know what kind of the data it is. But after clustering, it falls into this cluster number 4, something like that. We can able to identify. That is how the machine will categorize the similar points together with some label. And this is my original data point. So this is how we can use. And if I wanted to test the same model with a new data point, and it will say like it will put that new data point as per the requirements or as per the characteristics of that point into the trained model. So that is how we can use this k-means cluster algorithm for clustering unlabeled data into labeled clusters. I hope it is clear. Like if you guys have any questions, like how this model works and what is the use of this k-means clusters, how it can be utilized in machine learning models. This is the use case. Like if I have any unlabeled data, so I need to transfer my unlabeled data into labeled clusters. So that is where we can use this k-means clusters. So, and also we looked at one example case, mall customers data set, where I need to cluster this annual income and spending score into different into 5 clusters. So this is how I mean transferred my unlabeled clusters into a number of 5 clusters. So I hope you got some idea about how or what is k-means clustering. And if you really like this video, please do like the video. And if you are not subscribed yet, please subscribe the channel. If you have any further questions, do please comment on the video. Thank you guys. See you in other video. Bye.